No, you have to subtract the absorbance of the methanol towards the absorbance of the pigment.
Like this polar solvent?
Yes?
So as the pigment dissolved in polar, so we
Yeah.
use methanol.
Yeah.
And to compromise methanol, like to compare with methanol, we use pure methanol.
Yeah, first methanol. Yeah. Where are the cuvettes? No. Okay, no problem.
Oh my god. On that room I forget.
Yes, what you forget?
Glasses.
Go and bring first. Here will be the cubit in this place. Oh yeah. Oh yeah. Here we have to. In both cubit we have to one in blank, one in sample. Yes.
Yes.
So first of all, in first we will put just a blank in both.
But for me, I didn't use
In this kind of.
second sample. And I used one cubit.
Oh, only one cubit? Oh, and how did you measure that then? Oh, like this?
We can first put one.
Yes.
And
Close.
Okay, so
Yeah,
first
okay.
step.
Yeah, okay.
It's like
Yeah.
Do you know after you will have
What is
to do
this?
it in autonomy?
What you have put? Coconut.
I said first
Yes.
I just put methanol on the cuvette.
How much quantity? 2 ml?
The same quantity. It's always the same quantity. 1.5 milliliters.
Oh, 1.5.
Because you use this curve.
Oh yeah.
Yes, dispenser. So
Yeah, okay.
this dispenser.
1.5 ml.
After you have to follow the pathway for the absorbance.
Okay.
So you put it in this direction because here you have the laser.
Oh yeah.
So you have to.
Which direction you told?
The clear part.
Yeah. And another?
This part.
Oh, green
this
part.
direction.
Yeah. Okay.
After you close it.
Yes. Just close and lift.
Yeah. And after.
Yeah.
I don't want to use my glove. You put on blank.
Oh yeah, blank.
Because it's a blank. Because you have to subtract the absorbance of just the ethanol.
Oh yeah.
The methanol, sorry. To have the absorbance of the chlorophyll, right?
Yeah. Okay.
So you put measure.
Yeah. Okay.
So I will take this. Normally all these wavelengths corresponds to absorbance for different pigments, except this one, 700.
Oh yeah, blank is blank.
Just for turbidity.
It means I could not understand.
Turbidity, yes. Because, for example,
Which one is value our?
Put this sample on the cuvette.
Blank one. Which one?
Some cells.
This is what?
Residual cells in the supernatant. You can have a bias.
Minus.
In your,
What?
methanol.
absorbance.
Methanol?
So you have to subtract the absorbance of the turbidity
Subtract?
at 750 to the
we need to
absorbance.
deduct this.
To avoid the bias
This very nice
because of the cells.
This right.
It's at last. When we put sample, then we remove this cell.
No,
Yes.
not to this part.
So we have to subtract
In
then?
your sample,
Yes.
this sample. You agree? You have this some cells destroyed by the methanol. But when I will put the sample inside this, you can have some cells which will pass into your cuvette, into your superinnatant, to avoid this contamination by the cells, because the cells have an absorbance too, but we just want the absorbance of the chlorophyll and the different pigments. So to remove the absorbance of the cells, you use this wavelength at 750 nanometers and subtract it to the absorbance of the chlorophyll.
It means just we put 1.5 ml, yes, now.
Yeah, we put one in this case, but I put just one. You know what? Why?
Why?
It just to concentrate, because we don't have a lot of cells inside our culture because it's the first day.
It means we should not have to have the same volume, or
What?
we have to same volume of both
From-
things,
Yeah.
methanol and sample.
No, it's not a problem because it's
Oh yeah, just why?
because you can see the laser can pass just in this part,
Oh.
not this one.
Oh yeah. Okay.
So
It's
this
up
one
to
is
half,
in
yes?
excess.
Yes,
it's
okay.
not a problem. You have a minimum to respect, but
Oh,
we are
must be
at-
half
at
of
the
this
minimum.
cubit, yes?
What?
Must be half, not less than half of this cubit. It should be.
Yeah, you can
Yeah.
see.
Yeah.
It's okay.
Yeah. Okay.
So now we will do the measure 3 times
Yes, yes.
because it can move on the time, and you can you click on preview? You can see the curve. You will see the curve on the absorbance of the chlorophyll. Just wait. Oh no, click on measure now, please. It will do from 200
Oh.
800, but it starts with 800.
Oh yeah, it is showing here.
It's automatic. It's no. What to
Yes,
do.
automatic.
It's no what to do.
It's nice.
Very smarter than us.
Yeah, here you have the absorbance of the chlorophyll A.
Chlorophyll. How to diagnose? Where is it? Chlorophyll.
B, sorry, and after you will have the A. What?
Because of-
you are looking for the chlorophyll here?
Yes, yes. Chlorophyll A and B.
You can see. Because
Which one?
it's
Oh.
a knowledge.
He's like
You have to read your
absorption
documents. You have to read it.
potential graph, you know, it's like this and this.
Oh, it means if the more wavelength.
No.
The
We have
chlorophyll is the
absorption
pigment.
potential graph.
Yeah, the are you agree with me? The chlorophyll is a pigment.
Yes, yes. Carotene has a maximum, yes?
Yeah, so everything have a maximum peak absorption
Yes.
for the light.
For the moment,
So you have to know where is it, you know,
yes, okay.
and you have
Between
the
four,
wavelength.
it is between 600 to 800. One is.
And here you will have the
Oh.
calculus with the wavelength,
Yes,
because
okay.
the chlorophyll A absorb at 2 different wavelengths.
Yes, okay. 652 to 7.
But for it depends, because
Okay.
for Chlorella vulgaris,
Yes,
it's
okay.
at 652
Yeah.
letters. And as I told you, you have cells, residual cells that you can see maybe here. So this is why you do the difference between the absorbance of the chlorophyll A and the absorbance of the dead cells.
Oh.
Dead
Okay.
killed by the methanol at
Okay, okay,
750,
Okay.
and here too. And after you multiply by the volume of methanol, so 1 ml, and the volume of culture, so 2 ml, because we concentrated 2 times
For the
to
moment,
have a big peak, because it's really weak. We are at 0.2. It's not a lot for absorbance, because absorbance is between 0.1 and 1. You see?
Yes, yes,
So,
yeah.
so for example, if I didn't concentrate it 2 times, yeah. So,
it seems for calculation of what value should I have to put in this and this, like from this graph,
yes, you will have the values there.
only this value blank.
No, not the value. This is just to show you
Oh,
the peak,
yeah,
the
yeah.
spectral peak. Now you can close it,
Yeah, okay.
and now you can click on sample and do it 3 times.
3 times.
Yeah, because we we call that
Yeah,
a
okay.
triplicate.
Yeah, okay.
Is it also written there? You have to
The
take
triplicate is
three and
to
means of
have
that.
an overview and
Okay.
do the average of
For
all your
for
values.
replicate. Oh, it's
It's a measure triplicate. Normally you have to do triplicates for your sample and triplicates for the measure too. And after you calculate the standard deviation of everything. This is why you have to be precise.
Do it, Prakash.
And this is we did it in duplicates. This is why you have the sample 1 and the sample 2. But normally it's in triplicates. But for the measure you can do it in duplicates.
Yes. Did
oh yeah.
It will
For
be-
sample one, Takumi, you can take sample one.
is it
this
already
first-
3 time run or we have to
No,
run
no,
it by 3
no,
times?
no, just one.
No, 3 times.
Yes, yes, I meant to
But
say
the triplicate.
both one. First value, this is first value.
Like run,
We can-
you
yes.
don't need to write, it will automatically
Oh,
write.
yes. In second, third time, yes.
Second. But here written we have to run 4 times.
And after
Yeah,
you
no,
can,
no problem,
in
we can
sample
write.
name, you can write the name of your sample.
Yes, Prakash. Like
For example, sample with the date of today and Chlorella vulgaris, for example, sample 1.
Oh, it is fluctuating like 88, 89. Yes.
here written we have to do 4 times.
We can do four
3
times.
times.
No, no, it's
Where?
it's for
For what?
For replicate, I prepared the chlorophyll A, B, and photoprotective catenoid 56 concentration were determined using the flowing relations, which means we can do the for replicate. He means
Yeah, but for the beginning, we can just do 2 because it's for teaching you. And
Okay.
we
Don't
take
have the time.
3 hours instead of 2. So imagine with 4 replicates.
Okay.
It's complicated. But you will have the equivalent of 4 replicates because you have a triplicate for the measure and a duplicate for the samples. You know?
you can take photo, Takumi, you
Yes.
from camera. You can take a graph as well.
And this is why you have to read the protocol first, because at this step you realize that you need 4 replicates instead of 2. So it's not good for your experiments. If it's important, you have to read first. You have to prepare your experiment.
It means what does it mean? The difference between 652 and 750?
You already explained.
We have to mid value.
Yeah, I just explained before.
Like this is the absorbent by to the other cell.
Yes.
This one.
Yes.
And this is for our desired like
Like-
pigment. So we have to subtract if there is something
Like what, for example?
like the cell debris.
Cell debris? Yes, okay.
It also absorbs some light.
Oh yes.
So we have to subtract because
But how to identify from
like this wavelength is only absorbed by the with that of
for debris?
You have it here.
Oh,
So
this
for
is for
example,
debris
the
only?
negative value means that you don't have debris, you know?
without
You don't have, because the absorbance is negative. If you had an absorbance from the dead cells, you should have a positive value
so why is negative?
because you don't have.
Nothing.
You have nothing yet.
We
You have
don't.
no dead cells because they are
Oh, it means
the pellets.
always I have to consider that as 750
Yeah.
for debris.
Hmm?
For what should I have to consider 750 for always this value?
Yeah.
For dead cell, or what can I consider? Because I am
They
subtracting
are
this.
dead cells.
Dead cells,
Because
yeah.
it's a measure of turbidity. Turbidity means that you don't have only liquids but solids inside your sample. Are you agree with me?
Yeah.
That before it was just Chlorella vulgaris on the tube.
Yes.
So we centrifugate once to remove the water. After we put methanol,
Yes.
we let it incubate,
Yes.
and now you have a
Oh,
pellet.
still yes.
So are you agree with me? But when I put this on the cuvette,
Yes.
I should put some dead cells from the pellet inside
Yes.
the supernatant.
Yes. Okay.
And those dead cells, they are solid and they can absorb at 750 nanometers.
Oh yeah, I understand now.
But we don't want this
Oh, it means so that's why we need to remove from
to
here.
subtract.
Oh yeah, understood. Now, thank you.
But in this case,